Hello everyone, welcome to another technical deep dive. My name is Cody, and in this episode we're going to provide a comprehensive overview of fences. We'll explain what they are, why they're such a fundamental component of the DeepHub, and how they may be used to spark a wide array of use cases and applications. Fences, also known as geofences, are virtual boundaries that correspond with physical locations on the globe. They may be created as polygons or circles using geographic coordinates of latitude and longitude, or local coordinates in meters. Let's take a manufacturing facility as an example. Each area of the facility dedicated to a different manufacturing process could be defined with a fence. When a trackable, such as a forklift, enters or exits one of these fences, corresponding entry and exit events are generated. These location-driven events are the bread and butter of fences and are tremendously useful. For example, this manufacturing facility has one area that is restricted. This area could be defined with a fence in the DeepHub, allowing the facility manager to be notified in the event that a person or a vehicle enters this restricted area. This notification would be generated by a region entry event of the fence. But we can take this a step further because region entry and exit events include timestamps. This opens the door to a plethora of location-based services and analytics through the integration of the DeepHub with other applications such as manufacturing execution systems. Having accurate, real-time data on dwell times could be used to identify bottlenecks, inefficiencies, and potential opportunities. With each process area of a manufacturing facility defined with a polygonal fence, the facility manager could determine how long each component spends in each process step area by harnessing the timestamps from the region entry and exit events. Let us now explore how you can begin managing fences through the Admin UI, the REST API, and the WebSocket API. You'll need to have the DeepHub already installed. There's a link in the video description with a step-by-step guide on how to do this. To create a new fence in the Admin UI, first click Create Entities, and then Fence. From here, a unique ID will be automatically generated, and you'll have the ability to add several optional properties, including a name, the floor level where the fence will be applied, where floor 0 is the ground floor. If a value is not provided, the fence will be applied to all floor levels. Timeout, tolerance, and delay properties. These allow for much greater flexibility in the way fence events are generated and utilized for advanced location-based use cases. We will explore these properties in a future episode of this series, so stay tuned for that. And the extrusion or height of the fence in meters. For more details on these and all fence properties, refer to our documentation linked in the video description down below. While these properties are all optional, the only mandatory field is the method by which you'd like to create the fence. For polygonal fences, there are 4 creation methods. The first is an extent-based geometry, where you specify the height and width of a rectangle in meters and provide an optional rotation value in degrees. Once that's done, you can set the location of the fence by entering longitude and latitude coordinates, or by clicking on the map at your desired location. Any modifications you make to the fence will display in real time. When your fence is ready, click Save. The next method is done by providing local coordinates in meters for at least 3 points of a fence and an optional rotation value. You can add more points to the fence by clicking the Add Point After button. Once that's done, you can set the location of the fence by entering longitude and latitude coordinates, or by clicking on the map at your desired location. We can see that the location of the fence is in relation to the first point we defined, whereas in the previous creation method, the location of the fence was in relation to the centroid of the rectangle. This is because the first point we defined here is used as the origin point. If required, you can modify the origin point by activating Advanced Mode and entering the coordinates of the origin in meters. The next creation method is done by drawing the fence on the map or by providing geographic coordinates of longitude and latitude. To begin drawing, simply click on the map to place each corner point. The fence must have a minimum of 3 points. To finish drawing, simply click on the first point you created. The final method of creating a polygonal fence is done by providing local coordinates relative to an existing zone in your DeepHub instance. To demonstrate this, I'll first adjust my viewing options to show all zones in this area. First, select the zone, then provide local coordinates in meters for at least 3 points. Fences may also be created as circles where the location and radius need to be defined. The first method of creating a circular fence can be done by providing geographic coordinates for the center point or by drawing it on the map. To do this, simply click on the map to set the center point of the fence. A default radius of 10 meters will be applied. You can adjust the position of the fence by dragging it. Similarly, you can adjust the radius by clicking one of the orange points and dragging to your desired size. Alternatively, you can provide a new value in the property field. You may also create a circular fence by providing a pair of local coordinates relative to an existing zone in your DeepHub instance. First, select the zone. Then, provide local coordinates in meters for the center point. If needed, add a value for the radius. If you need to modify a fence, first click Fences at the top of the screen to pull up a list of all fences. Find the correct one and then click Edit. Alternatively, you can search for a fence to quickly pull it up and then begin editing. From here, you can modify the properties of the fence or delete it. Custom properties can be added that are specific to the application or solution using the DeepHub or the physical area that the fence represents. For example, if a fence is created to represent a particular manufacturing production process area, such as assembly, a custom property could be added that lists the parts being assembled within the area. In this way, location information can be paired with associated metadata right within the DeepHub. Once I'm done, I'll hit Update. Once your fences are created and configured, they can begin generating fence entry and exit events when trackables and location providers enter and exit them. Within the map view, they will turn green during an entry event and red during an exit event, making it very clear at a quick glance what is going on. The DeepHub REST API has several endpoints to manage fences, allowing you to create, update, and delete fences, and fetch information attributed to specific fences. We'll highlight a few of them here. The post fences endpoint may be used to create a new fence. You must provide a unique ID and specify the region. The region defines the geometry type for the fence, either a point or a polygon, and its associated coordinates. The coordinates relate to the coordinate reference system, but these are typically provided as longitude-latitude pairs with an optional Z component. In other words, if the fence is elevated above the floor. Aside from the properties that were already discussed, you may also provide a foreign ID, coordinate reference system, zone ID, or elevation reference. A foreign ID from an existing zone in your DeepHub instance can be provided so that it is used as the foreign unique identifier of specific fence events. The coordinate reference system is the projection identifier that defines the projection of the fence region coordinates. This needs to be either a valid EPSG identifier or local if the fence region coordinates are provided in relation to a zone, where the coordinates would be XY pairs in meters. The default value here is EPSG 4326, meaning geographic coordinates of longitude-latitude pairs. If the coordinate reference system is set to local, you'll need to provide the zone ID related to the fence's region. A 201 response confirms the request was successful, and we can see the newly created fence in the UI. geofences returns an array of all fence IDs, and geofences summary returns an array of all fences and their properties. The latter is a quick way to get a summary of all fences in your DeepHub instance. You can also get a summary of a specific fence with the geofences fence ID endpoint by including the fence ID in the request. Additionally, there are GET requests that may be used to fetch information on DeepHub entities that are located within fences, such as location providers, trackables, and trackable motions. In the UI, we can see that there are two trackables currently inside this fence. I'll use the geofences fence ID trackables endpoint to extract this information in a comprehensive manner. I'll provide the fence ID, and set the spatial query parameter to true. This will ensure that the query is solely based on the last reported location of the trackables. Otherwise, this query would take timeout properties into account. A 200 OK response confirms the request was successful, and the returned array includes both trackables. To update a specific fence, you may use the put fences fence ID or the patch fences fence ID endpoints. The former replaces the entire resource with what's provided in the request. The latter performs a partial update with just the properties that need to change. In this way, the patch request provides a convenient method of updating one or more properties without having to include all properties in the request, even those that are not being modified. I'll use the patch request to add a floor and extrusion property to this fence and also replace the name. A 200 OK response confirms the request was successful. In the UI, we can see that the updates have been applied. The fence is now on floor 1, has an extrusion of 2 meters, and its name has changed. You may also delete a specific fence or all fences at once. For the former, I'll use the delete fences fence ID endpoint by providing the fence ID. Using the WebSocket API, a WebSocket connection can be established with the DeepHub to subscribe to fence events. Through this connection, your application can receive real-time fence events and harness them however you see fit. To demonstrate this, I'll use a WebSocket client to subscribe to the fence events topic. As fence entry and exit events are generated, corresponding WebSocket messages and their payloads are received. The message payloads contain critical information such as the fence event type, the timestamp of the entry and/or exit event, and the trackable and/or location provider that caused the fence event. We'll cover WebSockets in much more detail in a future episode, so stay tuned for that. As the administrator of your DeepHub instance, you now have everything set up in relation to your fences. We recommend exporting all the entities in your DeepHub instance to back up your data. This will ensure that, if needed, you can quickly set up your system again. This can be done directly within the UI by going to Settings, and then Import and Export. Select the necessary entities, and then click Export. We've only scratched the surface in terms of what can be achieved with fences in the DeepHub. By strategically harnessing fences and fence events, your application can be further enhanced with real-time location-based analytics and data. We encourage you to explore fences for yourself and leave any comments or questions down below. Thank you for watching. Please like and share this video if you found it helpful, and subscribe to our channel for more future DeepHub content.